Right, this is the last thing we're going to do here. Actually, we're going to do one more example after this. But look, this has to be in radians. So you're not going to go 30, or radius 5 times angle 30. Okay, you got to take that and put it in radians. So again, this is not drawn to scale, obviously. That's not 30 degrees. It's way more than 30. But let's just keep 30 for the sake of argument, okay? So 30 degrees. I need to change 30 degrees into radians. So let's just do that one more time. You might remember what it was from that picture. I don't know. But let's do this. Yeah, you put 180 on the bottom. And now I always do that first for some reason because I know degrees is on top. I'm going to put degrees on the bottom. All right? Then put pi right here. That's once, that's 6. So it's pi over 6. Okay? So it's pi over 6. So if I want to find the arc length, you know what we're finding here, right? Not the angle. I'm finding how long that is. If that was a piece of string and I wrapped it around the circle and stretched it out, put it on a ruler, okay, I'm finding out the length of it. Everybody got that? Okay, so it's the distance is equal to r, which is what in this case? 5, that's in inches, and times the angle in what? Radians. It's got to be in radians, okay? So it's pi over 6.
So it'd be 5 pi over 6.
That's it. Let's actually get a decimal approximation out of it, okay? 5 inches. So it's 5 pi over 6. So there it is. Okay, so it's 5. On this calculator, it's right here. It's the second function. Oh, it didn't hit second. There it goes. I got to really press hard on this calculator thing. So it's 5 pi. No, that's what it was written in. So I just kept it in inches.
Okay,
Then you keep it in centimeters,
so the
yeah.
distance is in whatever unit the radius is.
Yeah, absolutely, sure. So it's 5 pi over 6. And then there it is, 2.6. We'll just shorten it to that. So, okay, good. So the distance from here to here, now if that was 30 degrees, obviously, again, that angle is not a 30-degree angle. But if this was 30-degree angle, which would be more about right in here somewhere, then this length would be about 2.6. That makes sense, doesn't it? Yeah. Yeah. And it's inches, right? Because whatever the units are right here, because radians don't have any dimensions, all right? And Dallas, that's why I was stopping you earlier. Radians don't really have dimensions. We say it's radians, but it's not like you can say, here's 1 inch. Well, 1 radian, it's always going to be the same measure as far as degree, but the distance that it covers for 1 radian is going to be different depending on how big or small your circle is. The angle is going to be the same. So they're really dimensionless. Yeah, Sarah?
When you did the 180 and the 30, is this coincidence that the 30 divided by 5 on the circle is 6 also?
Yeah. What was 6? Well, it's because it was a 30-degree angle. I mean, we remembered a 30-degree angle is 5 pi over 6. Is that what you're saying?
Yeah, well, you did like the 30 over 1 times pi over 180, and that came out to be 6.
Or actually, it was, yeah, it's 5.
Is it just coincidence that...
No, it's because we used a 30-degree angle. If you use like a 27-degree angle, it's not going to come out not real pretty like that. You have to chuck it in a calculator. I'm not sure what you're saying. We got to move on. After we stop doing the lesson, maybe I'll try to answer that. But really, we only have a handful of minutes here. We have to finish. Okay. I don't think it's a coincidence. I think it's because you use 30 degrees, but I'm not sure where the 6. I don't. What are you saying about the 6? This? It's a 2.6. It's a 2.6. This is a 2.6. Right.
That's 30.
It's because radians, because look, because this went right here. I'm not sure what the coincidence part is.
Sarah, the 0 with the slash, she just has to be in radians.
All right, we have to do another example. We got to move on. Time is running out. We have to finish, okay? So let's take a look. I'm doing an example from the book if you want to follow along. It's in page 820. But it says a monster truck. Okay, it's got a tire with a radius of 33 inches. Okay, let's pay attention here. You can work on that problem later.
I have one really fast question.
Oh, okay. Quick.
Did you say that a radian is always, the measure of 1 radian is going to be the same no matter what size the circle is? Is that right?
That's correct, because it's an angle. Yeah, the same thing with 30 degrees.
1 radian, it's always the same angle measure.
Right,
Okay.
exactly. I mean, like 30 degrees is always 30 degrees, no matter if it's a giant circle or a little tiny circle. Same basic idea. We got to keep going. The radius is 33 inches. It's a big monster tire. So it is, I mean, look, 33 inches is about this wide. You can't see on YouTube, but I'm holding my hands out, okay? So it's about 33 inches. So that means the diameter of the tire has got to be way out here like this. So at that, I would call that a monster tire,
Yeah,
wouldn't you? Okay. All right. So figure 66 inches. What is that? 5.5 feet. That's the diameter of the tire. That's a monster tire. Okay. So it says, has a radius of 33 inches. How far does a monster truck travel in feet after just 3/4 of a tire rotation? 3/4 of a rotation.
Well, can you flash
Okay.
circumference for that
And
radius?
how far? Well, we're going to do it with this thing right here. How far does it travel? All right. Let's go to this. All right, let's put a circle on here. Now, watch what's happening here. Let's think about it. Let's put a
You have to
radius.
measure- you have a 270-degree angle.
Right. Let's do this. Okay, there's the radius. Okay, it's 33 inches. Everybody got that? Okay, so that's 33 inches. Now, it says it only goes 3/4 of the way. So watch. Now, if it was going along a straight line right there, as this thing, it's supposed to be a straight line, as this thing rotates 3/4 of a way, it travels horizontally that way, doesn't it? So whatever the distance around this is, 3/4 of that distance is going to be the same translated horizontally. All right, so what I'm going to do is, let's draw another line. So as this thing rotates, what happens? This thing moves here 3/4 of the way. Where does it end up? Straight up here, doesn't it? Okay. So really, what are we finding?
The arc length.
Yeah, we're finding that arc length from here all the way to here to a what? 270-degree angle. Now, that's what we're finding. So we're trying to find that distance. Does that make any sense? Let's look. It rolls, doesn't it? It
Yeah.
rolls. And as it rolls, okay, this thing, the wheel touches the ground, okay, and it moves a certain distance. How far is it moving? Now, again, this is going to be sloppy, but that's okay. Whoops, there we go. It moves that distance. See that distance right there? That's the same distance that it goes across the ground. All right? That's how far it travels. Does that make sense?
Yeah.
So how do we find that? Well, that's an arc length. How do we find the arc length? S equals r theta. S is the arc length, equals the radius, which is 33 inches. And is it times 270? No, it's times whatever it is in radians. All right, so let's do it real quick. You had your little chart. You could just look, or you could just do this. Yeah, and we talked about it already, but let's just do it. So, all right, so look, the zeros cancel. 3 goes into this. Actually, what? 9 goes into those. 9 goes into that 3, and 9 goes into that twice, and it's 3 pi over 2. Agreed? So this is 3 pi over 2. Now, it may not come out nice and pretty, you know, like to one of those special angles, but that's why I use a calculator. All right, so it's, yeah, I would just go 99, wouldn't you? Because 3 times 33, 99 pi divided by 2. All right, 155.5. So 155.5. Now that's in what? That's in inches. Now, I didn't write this down. I should have. But they say, what would it be in feet? How would I change that into feet? Divided by 12. Okay? So it's that divided by 12. All right. Where's this right here? And just divide that. I'm not doubting you. I just want to show it. 12. Let's say about 13. Okay, so we'll say approximately 13 feet. That's how far it traveled, just going 3/4 of a way around. All right, you got that? All right. Let me give you an assignment. It seems like a little bit, and it is. This is a little bit to do. So you really need to make sure that you put some time. All right. Well, you have this as well. You're welcome. This is page 821, and we're going to go 11 to 40. Actually, some of these really don't take that long. Some of them are pretty short and easy to do. But, you know, that's what happens when you're in Algebra 2. You got stuff to do, don't you? All right. Everybody good with that? All right.
Wait, where is it? Did you write it down?
Watch it. It's right there. Right there. I just circled it, made it red and everything. All right, see you guys.